This was early on in my career. Matter of fact, I was still a trainee at the point when this happened. You see a picture here of a wave trap installed on a downcomer in a 500 kV substation. Looks fairly innocent, right? The job for this day back in 2008 was to replace this wave trap. We were upgrading to a new wave trap, and so the job for that day was to switch out a service, establish a protective work zone, apply grounding, apply bonding, and go up and replace this wave trap. So we're working with a foreign utility. Okay, the 500 kV line that left this station went to another utility. Okay, it ended up, so we start the process probably about 8 o'clock that morning, and then things stall. Okay, there's a 4-man crew working this job. Okay, one of those individuals was a trainee, one was a journeyman electrician, the other 2 were electrician leaders. All right. Ended up at the end of the day, it was about 2:20 in the afternoon till we finally got our permit applied to this work zone. By that time, the trainee had left, okay, and headed back to his normal area for his quit time at 3:30. And so the 3 elder, I shouldn't say elder, the 3 more experienced gentlemen were there, and this is when things started to take a turn, right? And so we always talk about, you know, nothing's that important that we got to take shortcuts, right? Nothing's that important that we need to hurry or rush or be pressured by time, right? And in this case, there was no time pressure, right? There's no customers out of service. You know, this is one of those routine jobs where we were able to isolate it in the system, affect no customers, no power flow, anything. When the crew finally got their permit at 2:20, the next step after and we call them permits where this happened. I know a lot of people call them clearances, same thing, right? So the clearance holder, the permit holder accepted that permit from the system operator. And then was issued at our 500 kV yards. There's actually gang-operated ground switches that go closed to protect our work zone. The key about those ground switches are, again, the conversation we just had, they are for tripping. They're not for personal protection. And so this 3-man crew that was left at the end of the day decided that they needed to get something done that day, right? Instead of taking a stop time out and saying, listen, guys, let's talk about this, let's think about it. We just had an evolution in isolating our equipment that took way longer than expected, right? And some guys were frustrated that we didn't get to do this job today. Worst case, it bleeds over into tomorrow. We come back tomorrow morning fresh, and we go at this job and make it happen, right? But these 3 individuals, 90 plus years experience in the substation world, 90 plus years experience. All of them had been there over 30 years working in the substation world. So they decide, okay, we have our permit, we have grounds closed at this station, we have grounds closed at the foreign utility station. I'm working between grounds. Remember I said a little bit earlier, hey, I have my high side, my low side isolated. In this case, same voltage, but I have both my sides isolated and grounded, right? So 2 of these 3 gentlemen get in a 60-foot JLG man lift, go up in the air, okay? You can see there's a set of parallel bypass leads that come around that wave trap. Remove those, okay? The last thing they wanted to do for the day was take off that piece of 4-inch bus that goes from the wave trap to the bus work below. And they wanted to take those other 2 leads coming off the bottom side of that wave trap off, so that all was left was that piece of 4-inch bus holding the wave trap. So that the next morning they could come in, put the boom truck up in the air, hook up the wave trap, lower it to the ground, lift the new one up and put it in place. So they go up, they start to take things apart, kind of in a hurry because we're nearing the end of the day. They take the bypass parallel leads off, they take the piece of bus out, they take one out of the two leads from the bottom of the wave trap, and the very last thing, or the next to last thing they did was remove the cable to paddle flat connection at the bottom of the wave trap from the second lead, the last lead that was remaining. Well, as you can see, or as you can imagine, right now that's their ground path, right? Their grounds, they have put up no temporary safety grounds to bypass around this open point they're about to make in this circuit, okay? They have in their mind the whole time, I'm grounded, I'm good. Well, one guy in the man lift holding that lead, second guy in the man lift operating the impact gun to remove the nuts and bolts from that paddle connection. He removes the last nut and bolt from the paddle connection, and when he does so, the journeyman electrician holding that cable to flat connection pulls it away, other hand on the rail of the man lift, and he just became the path to ground, okay? Not sure how he's not dead. Seems, I'd probably want to say 15 to 20 seconds. At a minimum, he was exposed to that induced voltage. The only thing that saved his life, I believe, is one, the man lift was not grounded. So another fallacy working in our stations, right? Hey, I'm on rubber tires. I don't have to ground, right? I'm isolated. Wrong. Now, in this case, because they didn't have the proper bonding and equipotential grounding in place, that might have saved his life. I don't know that for a fact. That's just an assumption. But luckily, the quick thinking of the guy on the ground to go over to the ground controls on that man lift, flip it to lower controls, and just literally drop the basket out of the air. Broke the connection between the induced voltage and this employee. Don't know how it happened. The second gentleman in the basket did nothing but freeze and duck down. He knew he had enough wherewithal to know that if I touch this guy, I'm going to be the second casualty, right? Whether that's injury or potential fatality. The bottom line is we cannot rely on grounding alone, right? We need to establish these equipotential zones in our work zones in the substations, right? Everything in there is metallic, right? All the structures are grounded, right? What's voltage trying to do? Trying to find its path to ground, right? And like I said earlier with safety principle number one, the current's going to go wherever it can. And in this case, it went through him. Luckily, he was not killed. He today has this arm just below the elbow, and he has this on his left hand. Okay? This gentleman was 6.5 months from retiring. Talked about it all the time, right? Moving out west, gonna go fishing, gonna go this, do traveling. Changed his entire life in that split second because they decided they needed to get something done that day. Guys, we cannot rush through this work that we do, right? We cannot do it. We need to take our time. We need to be deliberate. We need to recognize these hazards, okay? We need to understand them. We need to understand when we're going to put ungrounded equipment or ourselves into a work zone that could potentially have hazardous differences of potential, right? This guy was very lucky, good friend of mine, ended up retiring, but basically spent half of his last 6 months till retirement in a burn center. Okay, surgery after surgery after surgery to remove dead skin and so on. So listen, not only did it change that guy's life forever, it changed his wife's life forever. It changed his family's life forever, right? We just cannot rush through this work. We need to be deliberate in everything we do. We need to recognize these hazards, and we need to keep ourselves safe.